Welcome back to All This Math. For today's lesson, we're going to be multiplying by using the distributive property. But before we get into that, I do want to make a comment about these people that are on this t-shirt right here. This t-shirt is in honor of the Haitian Revolution. The Haitian Revolution took place from the year 1791 to 1804. It was a very important struggle, a very important battle that our African brothers and sisters won. Oftentimes in school, we find out about, the history of people of African descent, and it's like we're losing. It's a lot of losses. They get discussed in a lot of school textbooks and public schools and charter schools and whatnot. That's why it's important for us to tell our own history, because there were a lot of wins, and the Haitian Revolution was one of our wins. In the Haitian Revolution, our African ancestors on the island of Saint-Domingue, which is now known as Haiti, they actually defeated not only the French, but also the British and the Spanish, and I believe there was some American support for that they also defeated. So this t-shirt highlights Macondo, Boukman-Dutty, Toussaint Louverture, and Jean-Jacques Dessalines. And it's because of this win, which is why there's so much pressure over the years that has been applied to the island of Haiti, and why there's so much trauma and strife and stress on that island when we hear about it in the news media and in geopolitical conversations. So it's because of that win. And again, the Haitian Revolution took place from 1791 till 1804, and it's very appropriate being that right now, while I'm recording this video, this is August of 2022. This is Black August, and the Haitian Revolution did kick off in the month of August back in 1791. So if you're familiar with the Haitian Revolution, cool. If you want more information about the Haitian Revolution, there's a lot of information, a lot has been written about it. There are multiple books, but probably the most popular book is Black Jacobins by C.L.R. James. And another book that I read where I learned a lot of information about the Haitian Revolution was a book entitled The Irritated Genie by Dr. Jacob Carruthers. So you might want to start in those two spaces, and then, do some other research on the internet, find some other things out, find some other books as well on the Haitian Revolution, because it's very important. All right, now, getting into the multiplication using the distributive property. Now, first off, how do I know that I need to use the distributive property? These are the questions that you have to ask yourself as a student when you see any math problem. You have to look for certain things and then ask yourself, well, what am I supposed to be doing here? Well, the instructions say to multiply, okay, but then you have to ask yourself, well, how do I multiply and what am I going to multiply? Whenever you see parentheses and you see an expression or a bunch of terms inside parentheses, this is called a quantity, right? We refer to this as a quantity, right? And there's a number outside of the parentheses, in this case, a 3.1, and there's no symbol between the 3.1 and the parenthesis. That means we multiply. Even though the instructions say multiply, that's just another giveaway that you need to multiply. So what you're gonna do is you're gonna multiply 3.1 by not just the first term right here, this negative 1.2x, but you're actually gonna multiply 3.1 by every single term inside the parentheses. So the 3.1 is gonna get multiplied by negative 1.2x. It's also gonna get multiplied by 3.2y. And then it's also gonna get multiplied by negative 1.1. So you got to be careful, because what a lot of people do is they would do 3.1 times negative 1.2x and then stop right there, and they'll just rewrite these two terms, right? Giving them an incorrect answer. So you want to be careful. You want to make sure you distribute, and this is why we call it the distributive property, because we're basically distributing this 3.1 to everything inside the parentheses. We want to be fair. Think of it that way. We want to be fair. You don't just want to give the 3.1 to the negative 1.2x. You want to give the 3.1 to everything. So we want to fairly and equal in an equitable way. We want to distribute the 3.1 inside this parentheses. So the way it looks is like this. I like to draw lines to show what I'm doing. So 3.1 times negative 1.2x, and then 3.1 times 3.2y, and then 3.1 times negative 1.1. So I did this work a little earlier. This is a good calculator problem. Hopefully, if you're not allowed to use a calculator, if you see a problem like this, if your teacher is not allowing you to use a calculator, or if you see a problem like this on a standardized test and you're not allowed to use a calculator on that particular portion, I don't know why you wouldn't be, I should say. But in the event of that, I have some other video content on how to manually multiply decimals together. you know, so, and I can put a link in the description section of this video if you need to see that. All right. But in real life, basically, and most often, we're going to use a calculator to do 3.1 times negative 1.2. And 3.1 times negative 1.2, let me get my paperwork, because I got this problem already worked out. You know what I'm saying? 3.1 times negative 1.2 is negative 3.72x. So we put your equal sign, negative 3.72x. So this is the product of 3.1 and negative 1.2, negative 3.72. Don't forget the x though, right? Don't forget the x, because what's happening is this is really negative 1.2 x's. This negative 1.2 tells us how many x's we have, right? Or how many unknown values we have. We have negative 1.2 of them. So then if you expand them by multiplying by 3.1, now you have negative 3.72 of them, which comes as a result of doing the multiplication. So then we're going to multiply the 3.1 by the 3.2. So then that's going to be 9.92y, right? And then we're going to do 3.1 times negative 1.1, which is going to yield negative 3.41. And this is going to be our final answer. And the way we know it's our final answer is because we can't combine any like terms because we don't have any like terms. Now, in case you don't know what like terms are, they're like this. Like terms are terms that are alike. It's similar to what it sounds like, meaning if you have a term that has a variable in it, like an x or a y, all the variables have to be the same and with the same exponent. So this has an x to the first power in it. This has a y to the first power in it. So these are not alike. They different. This is just negative 3.41. That's just a rational number. This has no variable in it at all, or with it at all. So this is not alike to either of these either. None of these three are alike. So you just write them separate. You can't combine them. You can't add them together. You can't subtract them. That's another thing a lot of people try to do. They try to like do negative 3.72 plus the 9.92. You can't do that because that's got an x in it and that's got a y in it. They like apples and oranges. You can't put them together. You cannot put them together. They're not like terms. So you got to chill. You got to chill. You got to know what like terms are. This is x. And I know earlier I said x to the first power. And somebody might be thinking, well, where the one at? I don't see no one. How's x to the first power? Well, that's a good thought that you have, because whenever there's a variable and there's no exponent written, we just understand it's understood. What's understood don't have to be said. We understand that it's x to the first power. Just like right here, we have a y. There's no one right here. There's no one exponent written. So that means that automatically it is y to the first power. That's what it is. All right. So you can't combine these because this has an x in it and this has a y in it, right? Now you could multiply them together, right, and consolidate them that way, or you could divide them, but that's not what's being done here. This is a plus sign that represents addition. You cannot add though. So you can show the addition, right? But you can't actually do it. I know that gets confusing to some people because it's like, well, what you mean I can't add? Why is a plus sign there? Well, it's a plus sign there to show that these two values need to be added together, but you could add them together only if you actually knew what x was and knew what y was. But you can't know what x and y is because this is not an equation that we can solve. This is only an expression that needed to be multiplied out, right? So you can't combine these because they're not like terms. You can't combine these because they're not like terms. You can't combine this and this because they're not like terms. So that's how we know that we're done, right? And that's very important. So whenever you approach any math problem, always know what you're doing. Ask yourself, what am I actually doing and how do I do it? If I'm supposed to multiply, what am I multiplying? How do I multiply? And when you're using a distributive property, make sure that you always multiply the outside number by everything. Not just some of the stuff, not just by the first term or the first two terms, but by all the terms, by everything that's inside the parentheses. If you don't do that, your answer not gonna be right. You know what I'm saying? And I want you to get the right answer. Now, I just showed you how to do this, but you actually learn it by going to practice. So, go find a bunch more problems like this and go practice. And I'll see you in the next video. Peace.